Okay, hi everyone, my name is Nan-Chen Chen. I'm a third-year PhD student from the University of Washington, and my department is Human-Centered Design Engineering. And it's my pleasure to present this paper, Challenges of Applying Machine Learning to Qualitative Coding. So the group I'm working with right now has been thinking about this topic for a long time, and that's why we have this paper here, trying to share some of our thoughts so far. And I look forward to the discussion session later to get your feedback and thoughts as well. So before I start to get into details, let me do a quick survey first to kind of fresh people up as well. So how many of you have heard of or have done qualitative coding before? Raise your hand if you did. Okay, we got some. So how many of you have know what is grounded theory method? Okay, we also got a few. So for those of you who have already know these things, the following part will be just a review for you. But if you have never heard of these things, I will just briefly work through some big concepts to give you some idea about what the other things I'm going to talk about later on. So qualitative coding is a research method that is widely used in many social science domains, and there are various ways about how this method can be conducted, but most of them kind of related or rooted from this grounded theory method. So grounded theory method, unlike other typical methods which usually comes from like some theoretical frameworks and then have some hypothesis derived, and then researchers go to collect some data. Grounded theory method is a reverse. Usually we'll start from data. Either it can be existing text data, pictures, or something like that, or some ethnography data, observational data, interview data, things like that. And then researchers get the data, try to come up with some way to categorize and organize the data and kind of iteratively construct theories. To give you a more concrete idea about this process, let me take a really little small example over here. So assuming that we are going to code a set of tweets which related to #DemDebate, which is Democratic debate. And what researchers usually do is start from a stage called open coding, and in this stage, what they do is like they would just really explore the data set and try to give some labels or which is called codes to the data points here. And here are some example codes I give to these two little tweets, and it's kind of related to, I think this is sarcasm to the candidates, or it's kind of, there's some hashtag is used to show rejection, or some hashtag shows support, things like that, or some mentioning accounts of the TV channels to make it like broadcasting the support, things like that. So this stage is really just freely explore and come up with idea, or just grab the concept or ideas that the researchers think is important. And later on in the next stage, which is usually called closed or focused coding, what researchers usually do is to kind of organize the codes from the open coding stage into a set of closed codes, which they will probably get rid of the codes that they don't think that is that important, but keep the ones that they feel more interested in, and then try to come up with more specified codes. For example, here is a set of example closed codes I have here. I would just mainly want to focus on things related to tags, or mentioning, or hashtags, and support and rejection to a candidate, things like that. And then I can apply those codes to the tweets over here. And notice that the key difference of this stage to the next stage is, to the previous stage, the open coding stage, is that I cannot add more codes when I do this closed coding, so I can only stick to these pre-select codes. But it's actually an iterative process. That if I found those set of codes are not important, I can go back or kind of do some refinement of those codes to iteratively make the codes more complete or more well-defined. And some other people also go to do some other stages like axial coding or selective coding, but I'm not going to the details about those stages for today, because this is not a tutorial for grounded theory method at all. But if you are interested in knowing more about those methods, you can. These are two books I just recommend for just take a look if you want to learn more about that. For today, I'll just skip the details. So as you can see, qualitative coding is really a very labor-intensive task. it really requires the coders to take a close look at the text and then think about the codes to give and then assign the code. So it's actually a really hard method for scale up. So, but nowadays the data sets are usually more bigger than like what humans can handle. Like tweets may have like million or more. So what they usually do at nowadays is that they will select kind of sample some subset of tweets and just code those sets. Because there will be a large portion of the data set remain underexplored, so it's possible that the theory social scientists come up with may have something missing, or there may be inconsistency in their theory that they don't discover. So as you can see, like probably there will be some people asking about, okay, then do we have some way to scale up the process by some kind of machine learning method? Yes, there are. There are some kind of method that people have proposed to use some kind of natural language processing techniques to generate some features, and then use some machine learning algorithm to train some models, and mostly for like close to coding. And then people also suggest that maybe there's some ways we can have interactive learning by having the machine learning generate the codes and then ask human coders to correct them. But as most of the automatic methods, accuracy is really an issue, and so is this case. That one of the example work I showed in the previous page, I think they have like 70 to 80% rate in terms of recall, but they only have less than 10% as precision, which means that a lot of instances which should be coded with a certain category are not funded by the machine learning model. So that is a very big issue. However, the key point for today is actually not about those machine learning accuracy. It's about there's actually more fundamental issues and other issues that we think it's important to think about for this specific group of users. So for the following, the rest of my time, I would like to divide my talk into two parts. Firstly, I will talk about some of the issues we discovered through the interaction with the social scientists, as well as our own experiences in qualitative coding, and some potential research action that we think is possible for like everybody to try to look at to see like whether we can have a better way to help support this task. So I will start from the issues. So the first issue I would say is related to lack of mutual understanding, this to trust issue. Because machine learning is a really sophisticated technique, so social scientists do not usually have those kind of process background. So it's hard to ask them to do like feature selection, selecting algorithm, parameter tuning, this kind of machine learning tasks by themselves. But on the other hand, for most of machine learning experts, they don't really have some kind of social science background. So it's hard for them to really understand what those sophisticated concepts that social scientists are looking for. And it's even harder for them to really tell what is the concept underlying a specific code means. And because they don't usually have social science background, so it's also hard for them to come up with features that really fit to what the social science is describing. So it turned out can be the situation that even though the machine learning experts can come up with some models to tell the social scientists that, okay, you can take those models to code your data set, the social scientists will say, okay, but what does that mean? How can I really believe the results? And one of our interviewees even told us that, I'm not sure if I can believe machine learning outputs because I don't think the keywords are enough to represent the concept I'm looking for. So you can see there's really a gap between the two parties, and then it's really a lack of mutual understanding on either side. The second issue is related to the fact that building a learnable model is not the primary goal for the social scientist. Because to build a really good model, it usually requires a certain amount of ground truth data. But because the main task of social scientists is really not to build a model, the main task for them is to do their analysis, come up with the theory they want to explore. So if the machine learning experts to ask the social scientists to label more data, social scientists may feel that, oh, I don't really have time to do that. that is not something I want to do. I want to spend more time focused on my analysis. So it's really hard for them to, for the machine learning experts to build some good models. And this is also related to the third issue that there are some natural conflicts between qualitative method and quantitative methods. Because machine learning usually performs better on the categories that has more instances because of its statistical natural. So, but that doesn't mean those categories can be important in a qualitative way. In other words, quantity doesn't necessarily mean significant in qualitative method. And even worse is that sometimes those categories have very few instances may be considered as noise in quantitative method. But from the qualitative aspect, which is more social science aspect, they may think even though those codes only have like a few instances, they may be the key concept they want to explore. So you see that it's actually another gap over here that caused the problem that they are not really communicating very well. So for potential future direction to solve the issues I just mentioned, we kind of come up with some suggestions, but we think there's more should be done on those all these directions. So let's start from the first direction. The first direction is related to the opening up the black box of machine learning, which we have been talking about that for all day today. It's related to the interpretability and the transparency of the models and the outputs. But we also want to add a point that it's also important to better link the features onto those social science contexts, which means that social science know what does that mean to use this feature from their domain knowledge. So previous work suggests like visualization can be a help, and we think that just having visualization doesn't necessarily mean it will help. So it really needs more exploration in terms of how we can really visualize those outputs or process to make it really like social science friendly. The second direction we will call it is to reimagine the use of machine learning in qualitative coding. So instead of trying to improve the accuracy of and make some automatic coders to replace human coders, we think it's important to try other ways. Which, for example, like this concept of machine teaching, this is done by some other people. The big concept is that we can treat the humans as teachers and the models as students. So this kind of interactive process for teachers to teach the student and student ask questions to kind of iteratively improve the model. That's the idea of machine teaching. But in our case, we think that the social scientists can also play the role of the teachers and the machine learning models are students. So like the social scientists can teach them the machine learning models about the concept they were looking for. But the key here is that through the process of teaching and the student asks the questions, it's actually a way to facilitate social scientists to reflect whether their definition of the codes or the concept they are looking for are not yet really clear or not, or there's some other content they may not consider before. So even though the result of the model may still turn out to be not really good to be an automatic coder, the process and the efforts that social scientists spend on teaching the machine model students are still valuable in a way that they are improving their own idea and concept of the theory. So that's actually helpful then, and it's not a waste of their time. So we think this kind of way to reposition machine learning in the coding practices is an important direction for more people to look at. Finally, we will say that the third direction is related to the previous two directions, which we think that more user studies should be done on understanding those social scientists, so more observations in interviews and contextual inquiries should be done on really knowing what's their need and what are the potential positions to put those machine learning into this target user group. So we really need to better understand their needs. So I would like to acknowledge the anonymous social scientists we work with and also the research group members I work with on this project, and also my advisor, Cecilia Aragon from University of Washington. So here is my email, so if you have any questions or you want to have more further discussion, you can check out and email me. And I also look forward to the discussion session later. Thank you.